Today we want to take a look at the idea of a tangent to the curve, which would be from the derivative, normal, which is the line perpendicular to the curve, and a look at second derivatives. So let's take a look at question number 1. We want to find the equation of the tangent line and then the normal line to the curve y equals x squared minus 1 over x to the fourth plus 1 at the point on the curve 2 3/17. So if I want to come up with the equation of my tangent line, I need a point, which I have, and I need the slope. I know that the slope of the tangent, or the slope of the curve, comes from finding the derivative. So let's go ahead and find the derivative of our equation. So if I want to find the derivative of y with respect to x, one way we can write the derivative is dy dx is equal to. Then we have a quotient. So if I have a quotient, I know that I start with my denominator squared, so x to the fourth plus 1 quantity squared. And then in the numerator, I'm going to start with the denominator, x to the fourth plus 1, times the derivative of the numerator, 2x, minus the numerator, x squared minus 1, times the derivative of the denominator, 4x to the third. I now have the slope of the tangent at any point on my curve. Well, we want to find the slope of the tangent at the point 2 3/17. So let's go ahead and find the slope when our x-coordinate is 2. So we want to find the slope when x is equal to 2. So I'm going to plug 2's in for my x's. 2 to the fourth plus 1 times 2 times 2 minus 2 squared minus 1 times 4 times 2 to the third all over 2 to the fourth plus 1 quantity squared. So I'm going to get a 17 times 4 in the numerator minus a 3 times 32 all over a 289. So that's going to give me a slope of negative 28 over 289. Now that I have the slope and I have a point, I can write the equation of the tangent. So for my tangent line, and I'm just going to keep it in point-slope form, I'm going to take y minus my y-coordinate, 3/17, is equal to my slope, negative 28 over 289 times x minus my x-coordinate, 2. But I also want the equation of the normal line to the curve. Remember, normal means perpendicular. So if it's perpendicular and I have my slope, I can flip it over and give it a negative. So now let's go ahead and find the slope. For our normal line. And if I flip my slope over and give it a negative, it's going to become a positive 289 over 28. So now I can find the equation of my normal line at that point. Y minus 3/17 is equal to 289 over 28 times x minus 2. We can look at this graphically too to see our original curve and our two lines. So let's take a look at our original curve there. And then notice that you've got your blue line, which would be the tangent line at that point, and your green line would be your perpendicular line at that particular point. And you can see how that made that nice, perfect 90-degree angle there. Now, let's take a look at question number 2. We want to find the equation of the tangent line to the curve y equals x to the fourth minus 6x that is perpendicular to the line x minus 2y plus 6 is equal to 0. So if my line is perpendicular to this line, then I'm going to take that slope from the line, flip it over, and give it a negative. So let's go ahead and find the slope of this line first. And if I have x minus 2y plus 6 is equal to 0, then of course we want to solve our equation for y. So negative 2y equals negative x minus 6. Divide everything by negative 2. And we get the equation of our line is y equals 1/2 x plus 3. If my tangent line is perpendicular to this, then that means that the slope of my tangent line is going to be a negative 2. So I know that the slope of the tangent is going to be equal to a negative 2. I know the slope. I need a point. Where is this going to happen? So to do that, let's go ahead and find the derivative and set the derivative equal to negative 2 and see which x my equation is going to have. So I'm going to have negative 2 is equal to, I'm going to take the derivative of my x to the fourth minus 6x, which is going to be a 4x to the third minus 6. And that's going to give me a 4 equals 4x to the third. X to the third is equal to 1. Take the cube root of both sides. And I'm going to get that my x-coordinate is going to be a 1. I want to now find out what y-coordinate goes with this. So if I'm looking for my y-coordinate of my curve, I've got to plug that 1 back into my equation for my curve here. So to find my y-coordinate, we've got y is equal to 1 to the fourth minus 6 times 1, and I'm going to have a y-coordinate of negative 5. So I know that the tangent is going to have a slope of negative 2 at the point 1, negative 5. So I can now write the equation of that tangent line as y plus 5 is equal to my slope negative 2 times x minus 1. Let's do one more with this idea of my tangents. For question number 3 now, we want to find the x-coordinate of any point on the curve y equals x to the third minus 7 plus plus 7, where the slope of the tangent is 26. So let's go ahead and find the derivative, because I know that the derivative gives me the slope of my tangent. So I'm going to find the derivative of y with respect to x. That's going to be equal to a 3x squared minus 1. And we want to know for what x is the slope of my tangent 26. So if I plug a 26 in for my derivative and solve for my x, I'm going to end up with a x of plus or minus 3.